Hey everyone, today we're diving deep into a piece of Kubernetes that's absolutely essential, but often invisible. The unsung hero that makes networking actually work. Kube-Proxy. So, to really get a handle on what Kube-Proxy does, let's use an analogy. Picture your entire Kubernetes cluster as this gigantic, bustling shopping mall. You've got shops opening, closing, and even moving locations all the time. It's organized chaos. Okay, so if the cluster is our mall and your applications, your pods, are all the individual shops, then Kube-Proxy is like this super smart, invisible security guard. There's one on every floor, at every corner, and its only job is to make sure that when you follow a sign that says food court, you actually wind up at a restaurant that's open for business, not an empty storefront. But what's the big problem this invisible guard is even solving? I mean, it all feels a little bit like a magic trick, right? So let's set up the trick before we go and reveal the secret. Here's the first part of the magic. In Kubernetes, you create this thing called a service, and it gets a single, stable IP address that never, ever changes. Think of it like the permanent sign in our mall that just says, the food court. No matter what happens to the restaurants inside, that sign, that IP address, stays put. Now here's where it gets messy. The actual shops, the pods themselves, they're anything but stable. A pod can crash, and a new one pops up with a totally different IP address. You might scale your application, creating brand new pods with new IPs. They can even get shuffled around to completely different machines in your cluster. It's just constant change. Which leads us to the central mystery here. If the sign for the food court never moves, but the restaurants behind it are constantly changing their locations and names, how on earth does your request always find its way to a working restaurant? All right, you ready? It's time to pull back the curtain. Let's see exactly how Kube-Proxy pulls off this incredible feat of network misdirection. And here it is, the big secret. Kube-Proxy isn't really a proxy in the way you might think. I know the name is kind of misleading, right? It doesn't actually sit in the middle and handle your traffic. No, its real job is to be a rule writer. It's a little process that runs on every single machine in your cluster, and it's constantly watching for changes and rewriting the low-level networking rules of the operating system itself. Now, it wasn't always this slick. The very first version, what we call user space mode, was like an old-school telephone operator. It would literally take every connection, put you on hold, and manually patch you through. Super slow, a major bottleneck. The modern ways, IP tables and IPVS, are so much smarter. They're more like city planners who just write a perfect set of traffic laws that create direct, high-speed highways for all the packets to follow without ever getting in the way themselves. So let's quickly break down these modes. User space, you'll basically never see it. It's history. For a long, long time, IP tables has been the default. It works by programming the Linux firewall with sometimes thousands of rules. It's solid, but can get a bit slow if you have a massive cluster with tons of services. That's why for the big stuff, the recommended mode is now IPVS. It uses the Linux virtual server, which is a true high-performance load balancer that's built right into the Linux kernel. It's incredibly fast and efficient. Okay, theory is one thing, but let's make this real. Let's actually follow a single network packet on its journey and watch Kube-Proxy's rules in action, step by step. So imagine you're inside one of your pods and you need to talk to another application. You run a simple command, curl, followed by that stable, unchanging service IP. You hit enter, and the packet is on its way. The second that packet hits the network, the operating system on the machine takes a look at that destination IP and just gets confused. It checks its map of the world and basically goes, I don't know anyone with this address. This doesn't exist. And bam, this is where the magic happens. Right before the operating system throws up its hands and drops the packet, the rules that Kube-Proxy so carefully wrote jump in. They basically scream, wait, stop, that's not a real machine, that's a virtual IP for a service. I know where it really needs to go. Here, let me help you. The technical term for this little sleight of hand is packet rewrite. The networking rules, whether they're IP tables or IPVS, perform a switcheroo. The destination address on the packet is instantly changed. That fake service IP gets erased, and it's replaced with the real live IP address of an actual healthy pod that can handle the request. And just like that, the newly addressed packet continues on its journey, arriving at a real pod. The pod sends back a response, and your application gets the data it asked for, completely oblivious to the incredible redirection magic that just happened under the hood. So you can really start to see why this little component is doing some serious heavy lifting. Let's zoom out for a second and just appreciate its role as a true unsung hero of the entire cluster. And here's a detail that is absolutely crucial. Kube-Proxy is not some central brain. No, a copy of it runs on every single node in the cluster. It's managed by a special controller called a daemon set, which guarantees that no matter where your application lands, the networking rules for all the services are right there, ready to go, and consistent across the whole mall. So what happens if one of them crashes? Well, for a very brief moment, any new connections trying to leave that specific node might fail. But this is Kubernetes we're talking about. The daemon set immediately notices it's gone, and its self-healing powers kick in, automatically restarting the process. It's built to be resilient. And its job doesn't even stop with these internal connections. It also manages the rules for getting traffic from the outside world in. When you use a node port service, Kube-Proxy is what actually opens that port on the node's main IP. And for a cloud load balancer service, it handles that final critical hop from the node to the right pod. So if you're going to take just one thing away from all of this, let it be this. Kube-Proxy is the invisible traffic cop on every single node, constantly rewriting its rulebook to make sure traffic going to those stable service IPs is seamlessly and automatically redirected to the real, ever-changing pods. So we've figured out how Kube-Proxy gets your traffic to the right pods. But that kind of brings up a new question, doesn't it? How do all those pods, scattered across all those different machines, talk directly to each other? Well, that involves a totally different component in the Kubernetes networking stack. And that, my friends, is a story for another time.